Okay, there seems to be quite a bit of confusion versus trying to go through and debug each person's program, which take me forever. I'm going to go through a working lab report that I've received received before, and I've kind of cleaned it up a little bit, and kind of what I'm looking for this lab here. You know, obviously this should be the the cover page, your name up there, and kind of go through the lab here. You know, the lab objectives. This is a standard lab report format. System requirements up there, and kind of go through what this should work for. Now, this code does work, so I'm kind of leaving this up there for you to look at. That there, and let me widen this here to where you can actually see this up there. So, okay. This is the main code. We'll simulate a heating, ventilation, air conditioning system controller. I've actually worked on several projects like this in the past. One of the companies I worked for did consulting work for Carrier, so we did some microcontroller and some Altera ASIC design. Actually, we used Xilinx for theirs and then did a custom chip. So I've worked on some similar systems like this in the past. To be honest, Carrier doesn't use free-scale parts. They're a pig company because they're very, very inexpensive. Okay, there's all the various functional updates that we have. All these functions that are written here, and we'll go through each one of those fairly quickly right here. So. Right here, unsigned char messages is a 3 by 17 array where it sets up the it's a global variable. Notice that we've got a few things that are not filled in there. So our initial mode is off. We got 1 is heat, 2 is cool, our set temperature, our calculation variable, and our displayed values right there. These are all set up. Room temperature from the sensor, the value calculation variable, and our displayed LCD, which is a relatively there. And our main program, we set up our port right there. Port T is our output right there. 8-bit resolution, right justified 1 scale per sample right there, and there's our free scaler. This is all part of setting this up. You should have done some of this in previous labs. We initialize our LCD, which I think some of you have had trouble with that. We'll go through that module. Initialize our keypad and turn all our LEDs off right there. Okay, now here we're just going to go through here, and this is just going to set up that there. We're just putting our little message right there. Display. Wait a second. Up there. Get a key, see if a key's been pressed, check to see if the mode's been pressed, temperature, select, see if either the temperature selects have been pressed. Get there. Now this is an infinite loop. This is the main part of our program. This is where everything happens right here. We go through the step by step right here. Now the first one here, this is the pause the message right there. That's why, and we do this three times right there. Then we have a delay. We check the key, we see the mode, temperature, we check to see the temperature, converts it, we read that there, and we update the display. So this is really the main program right there. So we go through these steps. Now the rest of this is our functions. This is where some of you might have trouble right there. Mode select, if key is equal to star, go to heat, that there, message heat, else cool, right there. So again, you know, we change our modes. We have our little debounce. Select temperature. If select temperature is less than 100, we increment it right there. In other words, we're there. We lower the set point. We subtract 1 from it as long as it's greater than 0. And we go through here and we calculate the weight of each digit right there. This is converting it back to ASCII is what that's doing. If you look at 48 right there, that's converting each digit right there. Display the 100 digit, the 10 digit, the 1 digit. This is our update. We check to see if our mode. We set to off. If it's 1, we set it to heat. And then these are our various messages that we have there. Right there. So again, you could do these differently. You could do this as message 0, bracket, and then have the full. I just opted to go this route here. For Mr. Read, it's a little tricky. We start the conversion. We wait for the conversion to finish. We get the value from the ADC. We can convert it from 0255 to 0190. We go through our calculations right here. Right there, this does our calculations. We round it up or down, and then we convert it to ASCII and display it out. Right there. And these are our delays. Right there, we have our various delays. Right there. This is our keypad code. Right there, and keypad code's actually a little further down. Here's our keypad code right here. Okay, here we go. And again, what we're going to do is we're just simply going to initialize our keypad. We put right there. We get our key, and again, basically we go through and we read the key. I'll leave that there. This is what our array looks like on our keypad. 0, 1, 2, 3, 1 down through. Activate all of our columns. And input is equal to that. Right there, return. And this is going through and setting up our keypad. I'll leave that there. And there, and as we're going through, and if key is equal to 0, this is the key that has been pressed. Right here. If the row bit is low, then the key is pressed. There's multiple keypad programs out there that will work. This is probably not the simplest one, but this one does work. And no key was pressed. Here's our LCD code. Our initial, send a command to it. This is a standard piece of code for that. Right there, you should have gone through this before. This is a command nibble. We sent 4 bits. This is to initialize our code. We initialize it to right there. Again, you should have gone through this before. If not, you can see it there. This puts a character out. This puts a string out. Right there. You remember that every string, it actually puts a string out. All it does is you pass it the address of an ASCII string, and it puts it 1 character at a time out. It's called put C. Right there. This is a position. Okay, this shows the location of the thermistor. Right there, this is some text that explains. This is the controller block. That should be part of your report. This is what it looks like when it's running. Up there. Heat mode. Cool mode off. Cool on. Right there. And then, of course, you explain what's going on. Of course, you have a conclusion. Then you answer the questions. That's basically the report there. I'm going to just go ahead and post this video. Let me just kind of go through and slowly go through the code again so you can look at it. I'm not going to post this code. I think there's a learning process involved in you at least typing this code if you have that there. And as you can see, there's a lot of code. This is a long program, especially the way it was done here. Okay. Right there. There's all your functional prototypes. This is our global message, which is modified various places. There. Here's our port initialization. Right there. Initialize the LCD, initialize the keypad. You turn all the LEDs off. Go through, and this is the main loop of our program right here. And right there, you can see that's the main loop of our program right there. Here's our various functions. And let me remove that. Here's our mode select. That's a relatively large function. Let me where you can see there's our function for selecting our various modes. Again, we're treating key as a global variable. I'm not so sure that that's no, yeah, char key is a global variable, so that has to be, in a better written program that would probably be passed to it. But mode select, if key is star, then we go to heat. If it's 1, we go to cool. 2, we go to or mode. If key is star, that means we're going into our mode select, and then we look at our various. We change our mode. So if we're in 0, we off to heat. We change it to 1. If we're in 1, we're going to 2. If we're in 2, we go to 0. So this just goes through our various modes. And notice that we're changing just the elements in this message 1. If we go back to our message prototype right here, this is our mode right here. We're just changing those variables right there. So our message is still staying relatively the same, and we're going off right there. So we're changing those off. Temperature select, again, that's basically we're raising the set point. All we're doing is taking our set temperature, we're adding 1. If we hit B, we're subtracting from 1. Right there. This sets our temperature. Again, we're changing our temperature, these 3 elements right here. Message 2, 11, 12, 10, 11, and 12. And that goes back to our global variable right here, where we look at our set temperature right here. It's these variables right there. No, the R is what we read. So again, we're just modifying that right there. Temperature read. Again, we're changing this our right there, set point temperature. This is our calculations. Again, we're looking at mode is 0. We're changing our messages right there. Right. This is our read. This is just reading the analog port right there to Mr. Read. Start a conversion, wait for it to be complete, get the value, and we convert it from 0 to 255 to 0 to 190. That's our temperature range right there. And then we round it up or down to the nearest degree right there. And then we subtract out the digits, and we change those again in that array right there. I'm not going to go back to that there. But there, here's our delay again. Right here. There. This is the keypad source file again. Now, in this particular case, they were all put in different files and linked together at the end, which is the way that you would normally do this. I'm not sure if they've done that. You could put these all in one file and do the includes at the top right there. This is our keypad code right there. Again, it's relatively, this particular one is a long one. There's simpler ways to read that. Again, this is the LCD right there. That's pretty standard. Every LCD code that I've seen looks very much like this right there. So the keypad, to be honest, where I'm using this from is actually kind of a drawn out one. There's probably better keypad code out there that you can use, but you can go ahead and use this here. And this is examples of the running code, so it does work right there. I'm going to stop this right here and post this. I'm not sure where I'm going to post it, but we'll see how big it is.